Have you ever wondered why today's AI is so smart? It can write poems, create paintings, generate code, hold conversations, and even produce entire video clips. But does it actually understand what we're saying? How does AI comprehend language, images, and the world around us? Today, we're going to break down the magic behind this seemingly intelligent technology and uncover the wonders of mathematics, algorithms, and computing power that lie beneath it. First, we need to clarify one crucial point. AI is not thinking, it is simply performing massive calculations. Every time you ask a question, it doesn't understand your request. Instead, it uses countless mathematical operations to predict which word is most likely to come next. Let's use an analogy. If I say, this morning I had a cup of what? I will calculate the probabilities. 0.8 for coffee, 0.15 for milk, and 0.05 for cola. So it chooses coffee. That's why ChatGPT isn't thinking. It's guessing based on probabilities, but guessing extremely cleverly. Then how does it make these smart guesses? The answer lies in a structure called an artificial neural network. Many people find neural networks mysterious, but their basic structure is actually quite simple. A neural network works like layers of information filters. On the far left is the input layer, for example. If we feed AI an image of a cat, the pixel data enters here. In the middle are multiple hidden layers, which extract features from the image layer by layer, like peeling an onion. First, they recognize lines and colors, then combine them into shapes like ears and eyes, and finally form the outline of a cat. On the far right is the output layer, which gives a IS result. This is a cat. A neural network is made up of thousands of nodes, similar to neurons in the human brain. Each node receives input, performs calculations, and then outputs a result. When multiple layers of neurons are stacked together, they form a deep neural network. The key to making a neural network work accurately is training. You can think of the training process like tuning a radio. At first, AI's answers might be completely wrong, for example, mistaking a cat for a dog. When this happens, we tell it that's incorrect. AI then uses this error signal to adjust the weights of each filter layer, just like turning the knobs on a radio. It keeps adjusting until the next time it sees a cat image, it outputs the correct answer more and more often. In reality, AI never understands what a cat is. It simply finds the correlation between pixel combinations and the label cat by adjusting weights. This is the illusion of understanding. So how does AI quickly complete so many adjustments? This relies entirely on mathematics. At the core of a neural network is the continuous optimization of a loss function, which minimizes the gap between the predicted result and the actual answer. How does this work in practice? Much of AI's smartness actually comes from the power of linear algebra and probability theory. Earlier, we mentioned information transfer between layers in a neural network. This is essentially matrix multiplication. For example, if the input layer has 100 pixels and a hidden layer has 20 neurons, the information transfer from the input layer to the hidden layer involves multiplying a 100 times 1 matrix pixel data by a 100 times 20 weight matrix. The final result is the output of the 20 neurons. In neural networks, most information processing is done through matrix operations. Besides matrix operations, the gradient descent algorithm is also core to AI training. We can imagine AI's training goal as finding the lowest point of a mountain. This lowest point represents the state where AI makes the most accurate judgments. Gradient descent is like rolling a small ball down the mountain. The ball rolls along the steepest path, the opposite direction of the gradient, until it reaches the lowest point. In AI training, this steepness represents error. AI adjusts weights along the path where errors decrease the fastest, gradually approaching the optimal training result. Here's a breakdown of the AI training process. When AI makes an incorrect judgment, it starts from the output layer and traces back, passing the error step by step to the hidden layers and input layer. This lets each layer know where to adjust its weights. This is the essence of backpropagation, using reverse error propagation to optimize the entire network. With a combination of matrix operations, gradient descent, and backpropagation, AI can continuously improve its abilities through training on massive amounts of data. But here's a question. If a model has tens of billions of parameters, how can a CPU handle so many calculations? The answer is GPU. GPUs were originally designed for gaming and image rendering. They have thousands of small cores and excel at parallel computing, the ability to process thousands of data blocks simultaneously. Matrix multiplication in deep learning happens to involve a huge number of repetitive calculations. GPUs can handle these in parallel, increasing computing speed by tens or even hundreds of times. This makes GPUs a perfect fit for the large-scale matrix multiplication needs of neural networks. That's why NVIDIA has become the king of computing power in the AI era. Every model training session relies on tens of thousands of GPUs working simultaneously, consuming millions of kilowatt hours of electricity and running for months. Today, the AI data centers of major tech companies are filled with GPU clusters, or even more specialized TPU clusters. This hardware acts like AI's energy source, providing a steady stream of computing power to support the training of large-scale models. For example, the training cost of GPT-4 is as high as tens of millions of dollars, with most of that cost going to computing power. The larger the model and the more data it needs to process, the more it depends on powerful computing power to support it. AI's smartness comes not only from good algorithms, but also from strong computing power. Of course, algorithms and computing power alone aren't enough. AI's intelligence comes from the massive amounts of data it has read. Large language models like ChatGPT don't actually work in a way as sophisticated as we might imagine. At their core, they're still predicting the next word. When we input text to AI, it calculates the probability of each possible next word based on the vast amounts of text data it was trained on. It then selects the word with the highest probability to continue the text, building coherent content step by step. So, an AI doesn't understand the meaning of words. It simply performs statistical pattern matching, combining words in the most likely way. For example, if you input, "The weather is nice today," I want to go to the what A will use the massive text data it learned from to calculate the probabilities of words like park or walk, then piece together a sentence. It never understands what a nice day feels like, nor does it know what a park is. It's just doing statistical matching. In short, algorithms are the skeleton, computing power is the muscle, and data is the soul. Now, the question remains, does AI truly understand human language? The answer is no. It only finds the most similar answer in a high-dimensional space through pattern matching. It has no real consciousness, nor any understanding of the world. Its smartness is merely the result of probability and pattern recognition. Surprisingly, however, when a model becomes large enough and is trained on sufficient data, this statistical machine actually creates an illusion of understanding. This is known as emergence. For example, some ultra-large models, even though their training goal is still to predict the next word, suddenly develop abilities they weren't specifically trained for after reaching a certain training stage. These abilities include simple mathematical reasoning or translating less common languages. Even so, this does not mean AI has gained true understanding. It is still finding answers through complex statistical patterns. AI has no consciousness. It is merely a wonder of human mathematics and engineering. It cannot possess emotions, creativity, or true logical thinking like humans do. If you want to truly understand the underlying principles of this intelligence, don't forget to subscribe to my channel. See you next time.